Hey everyone, it's Gabriel again, and today I will be explaining the final part of my Java chat app application. Let's begin. I started with modifying my generateMessageID method, as the previous method in part 2 only included 10-digit values that couldn't start with zeros. To start, I changed the message ID variable to string data type, and the method changed to return string. I still used the random object from the random class and proceeded by creating a variable called number equal to a randomly generated number less than 1 following 9 zeros. The reason why I changed this method is because data types int and long wouldn't allow numbers starting with zeros. String.format will convert the number variable into a formatted string. The regex %010d can be broken down. Percent means the start of the format instruction. 0 means add zeros before the digits 1 to 9. 10 ensures that the total length is 10 characters. And d means the value is a whole number. The return value is then a string. Look at the main additionality to the app. I imported the following classes: java.nio files, java.nio.file.paths, and java.util.list. These imports will be used for the stored messages method. The aim of this method is to allow for multiple parallel arrays to store each message object's respective fields across multiple indexes, with each index across arrays being one message and its relevant details. JSON equals new JSON creates a new JSON object from the JSON class. This will allow us to convert the JSON data into a message object. Stored index equals 0 is used to reset the index of stored data in the arrays. Hence, the first message object's fields are stored in parallel arrays using stored index equals 0. Try and catch blocks are used to execute code. The try block executes to try store the fields of the message object, but if the file doesn't exist, the catch block executes code that presents an error message. Paths.getMessages.json uses the paths object and its method .get to create a path or address where the rest of this method can access the file. Files.readAllLines is used in conjunction with the paths method by reading each JSON object into memory and storing them in a list interface. List string describes the interface in which each element of string will be stored. The variable lines will hold each line of the file as a string, with each string containing the text of a JSON object. A for each loop is then used for string lines in bracket. The loop basically makes the variable string line equal to the first string text up till all the string lines in the list are covered, with the first iteration of the line variable being manipulated till the last string in the list. Line.trim will remove any spaces on either ends of the JSON text. If !line.is black, checking whether the line is empty or not. If it is not empty, it will execute the following lines of code. Message temp equals json.fromJSON. Line, message class will convert JSON into the message object, filling in its fields. Then we can use this temp object to use getter methods to get each message's important information and stored it in parallel arrays synced by the same index, stored index. Stored index ++ will then allow for the next position in the parallel arrays to be populated. The catch IO exception E will then run if something goes wrong with the reading the file. The system will then print out the error message by using e.getMessage, the method that will be used to run and display the stored messages and its choices. is called View Modified Display Messages. Let's start with the first message that is called when the user presses A, calling the display sent messages method. A string variable is declared and is initially set to be an empty string. This method makes use of the sent index number to keep track of sent messages. This index number is used in process sent message method, where the sent message array uses this index number to track which index each message is stored in the array. Sent index number will then increment by 1 after each sent message. As we can see, this same concept is applied in this method, except a for loop is used to capture all sent messages added to one variable. Furthermore, an if statement is used to only allow commas between sent messages. Sent messages is then returned and displayed to the user. Next method is called display longest stored message. This method will return the longest stored message, that is, whether the message is stored, sent, or disregarded. This method makes use of index counters, sent index number, stored index, and disregarded index number. We look back at the process sent message method and can see that for case 2, disregarded message hashes, messages, and recipient numbers are all stored in parallel arrays using the stored disregarded index number. To begin, the method starts with a string variable longest message, which is empty. The first for loop will loop through the sent message indexes, and each time a longer message is found, it is then equal to the variable longest message. Next for loop. This for loop instead regards the disregarded messages stored and also compares whether the sent message is less than or greater than the length of the disregarded messages. If one message is longer, it is equal to the longest message variable. The same concept is also used for stored message array, using the stored index counter to keep track of looping through the for loop. The longest message is returned, or an error message is displayed if no messages were deleted, stored, or sent. The next method is string search recipient message, which takes in values from the view modified display messages method, that being the user's input and the Boolean value false. With parameters called string message ID input and Boolean unit test, message hash and ID index is used here and in the process sent messages method. It is used to create parallel arrays where each array, such as message hashes, message IDs, all recipients' cell phone numbers, and all messages arrays are synced by one index being message hash and ID index. Two variables are declared, string result being an empty string, and string search ID, which is equal to the input from the user. That is, if the user types in the correct message ID. The for loop runs looking for where the inputted search ID equals any message ID that is stored, disregarded, or sent. We will come back to the if unit test statement later. For now it is false, so the if block won't run. Instead, normally the application will run the else block using the plus equals addition assignment operator to add to result variable the recipient's cell phone number and message. Once all indexes with the information are checked, the message returns the result to the recipient. If there are no messages anywhere, the system will display the message ID is incorrect or there are no messages were stored or no messages were stored. The next method is search for message using recipient, which again takes in a parameter. This parameter is string recipient number. This method is similar to the previous method as it checks whether the inputted recipient number is equal to the index of stored recipient numbers called all recipients. It makes use of the sent index number to provide a way for the all recipients array to know when all sent messages have been checked. The key concept here is string result starts off empty, and the if statement not equal to result.equals empty string will execute code. If result doesn't equals empty string, it will add a space. This ensures that there are spaces between each message regardless of whether it is stored or sent message. If result is still empty, an error message is shown. The result is then displayed to the user. The next method is string delete message, which also takes in a parameter inputted from the user called string delete message hash. Two variables are declared: string result, which is empty, and boolean match, which equals false. The first for loop is used to determine if there is a matching message hash or stored message, and if there is, it will delete the stored messages fields. The second for loop makes use of message hash and ID index. It will erase arrays such as all messages, all recipients, message hashes, and message IDs, although result is captured before to store the message. This for loop also changes the match variable value to true. The disregarded for loop clears all values in the disregarded array if there is a match. The for loop that uses sent index number. This loop is slightly different as it checks whether the message stored in the sent message array's indexes equals the result. If it does and the array is not null, it will clear the sent message arrays. Lastly, if match is true, a successfully deleted message is shown. Last method, string report generation, starts by declaring a string variable report that is empty. The addition assignment operator plus equals adds the string sent messages to the report variable. An if statement is used to check whether there are sent messages. If there is a sent messages, a for loop is run. The for loop checks if indexes are null. If they aren't null, a report is given showing the sent message hash, sent recipient number, and the sent message. This process is repeated for the next two blocks of code, where string is further added onto the report for information regarding stored and disregarded messages. Report is returned and displayed to the user. We now move on to the first method of the JUnit test called sentMessageArray correctly populated. A message object is created and a recipient number, message, and number of messages is passed into the constructor. Hence the object's fields become equal to these values. The object calls the method clearMessageFile to ensure there is no stored data in the JSON file. The object calls the method processSentMessage and passes the value 1 into it, indicating the message is going to be sent. The next part does the same process, except setter methods are used to update the values of the object's fields. Messages again are sent, stored, and deleted. Assert equals runs comparing the two sent messages to the actual result when calling the display sent messages method. The next unit test method is called display longest message. Values are passed into the constructor like before as well, as the clearMessageFile method is called. Messages are sent, stored, and deleted. Assert equals then compares the expected result message with the method called by the object display longest stored message. The next method, searchMessageID, is used again as the object is created. The next method, searchMessageID, is used where the object is created with values passed into it into the constructor. The message ID is set to 0838884 4567 and the message is sent by case 1. Assert equals expects the sent message to be outputted. The actual result compares to the expected by using the message object to call the method search recipient message, in which the same message ID is passed into the method and the Boolean value is now true. By setting the value to true, the method will run the code displaying the message corresponding to the message ID inputted. The next method is search recipient number to message. Again, values are passed into the constructor and the message file method is called. Two different messages are stored for case 3 with the same recipient number. The object message calls the method search for message using recipient, in which a getter method is used to pass the recipient number into the method. The next test is delete message hash. Again, values are passed into the constructor and a message object is created as well as the clear message file method is called. The process sent message method is called with case 3 being inputted, therefore the message is stored. Assert equals compares the expected result with the actual result. That is, the message object calls the method delete message with the getter method get message hash as the input. The last method, display report. Again, a message object is created and values are passed into the constructor. The message process sent message runs with case 1 being initialized, indicating the message will be sent. A string variable message sent first hash is used to hold the first message hash of the sent message. Setters are used to update the object's fields, such as the message and the recipient cell. The process sent message case 1 is called again, and similarly, string message sent second hash is used to contain the message hash from the new message. String expected report holds the expected report of what the report should be if these values are used. Assert equals compares the expected report with the actual report, which is called by the object message, calling the method report regeneration. Thank you guys for listening. I hope I have helped you in some way learn more about Java.